यस, गुड इवनिंग एवरीवन। तो आज हम डिफरेंशियल इक्वेशन ही कंटिन्यू करने वाले हैं। ठीक है, जो जहाँ पर हमने एंड किया था उसके आगे हम वी आर गोइंग टू कंटिन्यू विद दैट। ठीक है। लास्ट टाइम पर हमने डिफरेंशियल इक्वेशन कुछ ये सिक्स प्रॉब्लम तक किया था ऑफ योर एक्सरसाइज 9.5, और अभी इसके आगे ही करने वाला है। ठीक है, तो लेट्स डू क्वेश्चन नंबर 7। पहले तो अभी यहाँ पर ये जो डिफरेंशियल इक्वेशन है, राइट, द काइंड ऑफ डिफरेंशियल इक्वेशन विच यू हैव इट इज व्हाट। यहाँ पर y अपॉन x ऐसे फॉर्मेट में है, तो पहले तो आपको ये चेक करना होगा कि वेदर द differential equation is homogeneous or not. Now to check whether it is homogeneous or not, इसके लिए आपको पुट अप करना होगा। ठीक है, आप x की जगह पर लैम्बडा x और y की जगह पर लैम्बडा y पुट अप करो, एंड देन फाइंड, देखो कि वो पूरा लैम्बडा बाहर आता है या नहीं आता है। ठीक है, मतलब लैम्बडा पूरी तरह से कैंसिल हो जाना चाहिए। ओके, तो यहाँ पर आपका पहले तो ये डिफरेंशियल इक्वेशन जो भी है दैट इज x इंटू कॉस ऑफ y बाई एक्स प्लस y इंटू साइन ऑफ y by x, and this whole into dx is equals to y into sine y by x minus x cos y by x, and this whole into dy. Fine. तो अब अगर मैं इसे dy by dx करूँ, so what I get if I say this is my dy और dx यहीं पर is equals to, ये पूरा as it is आ जाएगा, that is x cos y by x plus y sin y by x, this whole divided by y sin y by x minus x cos y by x. Fine. So this is what your dy by dx is. ठीक है. Now what we will do, we will find the dy by dx at f of lambda x and f of lambda y. क्या करेंगे? We will again find dy by dx, okay, at lambda x and lambda y. So what it is? यहाँ पर जहाँ पर भी x है वहाँ पर lambda x रखो. Cos of lambda y upon lambda x plus lambda y into sine of lambda y upon lambda x, the whole divided by lambda y into sine of lambda y upon lambda x minus lambda x into cos of lambda y upon lambda x. Okay, so if I solve it, ये lambda अंदर अंदर कैंसिल, ये भी आपका अंदर अंदर कैंसिल, ये भी कैंसिल और ये भी कैंसिल, और अगर ये lambda अगर ये पूरे इसमें अगर मैंने कॉमन ले लिया तो वो भी कैंसिल हो जाएगा आफ्टरवर्ड्स। मतलब अगर समझ लो, if I find what is dy by dx at lambda x comma lambda y, so what you see is अगर आप lambda कॉमन ले सकते हो then x into cos of y by x plus y into sin of y by x, this whole divided by, again यहाँ पर भी lambda आप कॉमन ले सकते हो, then again what you have is y into sin of y by x minus x into cos of y by x. Now what you see that ये भी lambda lambda cancel, तो पूरा का पूरा आपका lambda निकल कर cancel हो गया. So therefore what we can say that the given differential equation is homogeneous. The given differential equation, the given differential equation is homogeneous. What it is? It is homogeneous. Okay. Now अगर homogeneous है तो what we can do, जो भी आपका differential equation है आप इसमें put up कर सकते हो, that is y is equals to vx और x is equals to vy. Depends on what you have. आपके पास dy by dx है बराबर, और पूरे टर्म में आप देख सकते हो कि y upon x है, तो what we will do, put y is equals to vx. Okay, तो what you have, x into cos of vx upon x. एक मिनट, before doing this we also find what is dy by dx. If I want to find what is dy by dx, it will be dy by dx is equals to v into derivative of x, that is 1, plus x into derivative of v, that is dv by dx. फाइन, तो dy by dx को हम क्या लिख सकते हैं, v plus x dv by dx, v plus x dv by dx is equals to, बाकी ये सारे टर्म में x को हम क्या लिखेंगे, as it is x. उसके बाद cos of v y can be written as vx, cos of vx upon x, after that plus y plus vx into sine of vx upon x. फाइन दिस होल डिवाइडेड बाय यहाँ पर क्या है y, दैट इज vx into sine of vx upon x, then minus x cos y by x, minus x cos vx upon x. फाइन ये x x कैंसिल, दिस x x, दिस x x, दिस x x. फाइन, तो आपका बचा क्या? दैट इज v plus x dv by dx is equals to x cos v plus vx sin v, the whole divided by vx sin v minus x cos v, बराबर. Now what you can do in this, ये v हम इस तरफ ले लेते हैं, so we can find what is dv by dx. So if I take this v on this side, so x dv by dx will be equal to x cos v plus vx sin v. एक मिनट, यहाँ पर vx ही आएगा ना, yeah, vx sin v. I can also take x as in common in this both also. एक मिनट रुको, before doing that I can take x as common in both of them, in the numerator and the denominator. So v plus x dv by dx, if I take x as in common in this, it will be cos v plus v sin v, the whole divided by, यहाँ पर भी अगर मैंने x कॉमन लिया तो v sin v माइनस cos v. So क्या हो जाएगा, ये x and x cancel. So what you get? So again x dv by dx will be equal to cos v plus v sin v upon v sin v minus cos v, and then ये v अगर right hand side आ गया तो it will be minus v. Fine. Afterwards x dv by dx is equals to, if I take this in the denominator, that is v sin v minus cos v, this into this is cos v plus v sin v minus v into this, that is v square sin v, minus into minus, that is plus v cos v. Okay, now what we can do, this is x dv by dx, ये v sin v and v minus v square sin v है, ये cos v and v cos v. Okay, this is v sin v minus cos v. एक मिनट, कुछ तो गड़बड़ हुआ है, एक मिनट रुको. प्लस y sin, oh, there is y outside over here, ये y रह गया, this y is remaining and even this x is remaining. तो यहाँ पर बाहर क्या आ जाएगा, wait, this y and x both are remaining. Okay, so this y and this x I haven't written it initially. तो आपका यहाँ पर dy by dx के ऑपोजिट साइड में अगर dy by dx है तो ये, तो यहाँ पर आपका y अपॉन x आना चाहिए. ओके, तो यहाँ पर भी आएगा, सब जगह आएगा, यहाँ पर भी y अपॉन x आएगा बाजू में. ओके, similarly over here also it will come y upon x, and y can be written as vx, y can be written as vx. Okay, over here also it can be written as, and that x got cancelled by this and यहाँ पर v रह जाएगा, right? So before taking this over here, wait, what we can do, यहाँ पर if you multiply this v, it will be v cos v, and if you multiply this will be v square sin v. Okay, और यहाँ पर v plus है already. If I take this v on this side now, so what you have, x dv by dx is equals to v cos v plus v square sin v upon v sin v minus cos v minus v. Okay, now if I do the cross multiplication, is equals to, you get v sin v in the denominator minus cos v, this into this it will be v cos v plus v square sin v minus v into this, that is v square sin v, and then plus v cos v. Okay, so what you see over here, this v square sin v and v square sin v दोनों आपका same है, तो you can cancel. तो what you get, x dv by dx is equals to v cos v plus v cos v. Yeah, everything is right. यहाँ पर v cos v plus v cos v, it will be 2v cos v upon v sin v minus cos v. Okay, अब यहाँ पर ये dx इस तरफ ले लो और dv इस तरफ ले लो, तो dv आपका यहाँ पर है और dx यहाँ पर है, एंड यू कैन पुट इक्वल इन दिस बिटवीन, तो यहाँ पर आ जाएगा v sin v माइनस cos v अपॉन 2v cos v, and this will be 1 upon x dx. So there can be something cancelled. Up v sin v upon 2v cos v करोगे तो v and v gets cancelled. We'll do it. V sin v upon 2v cos v minus cos v upon 2v cos v, and that is dv the whole is equals to 1 upon x dx. Now this v and v gets cancelled. Sin v upon cos v is tan v. So 1 upon 2 tan v minus cos v and cos v get cancelled. Minus 1 upon 2v is equals to dv is equals to 1 upon x dx. Fine. इन दोनों में आप 1 upon 2 कॉमन निकाल सकते हो. So what you get? Tan v minus 1 upon v dv is equals to 1 upon x dx. Fine. After this, I can take this 2 on that side. So tan v minus 1 upon v into dv is equals to 2 upon x into dx. Now what I will do, I'll do the integration on both sides. Okay. Now what is integration of tan x? Integration of tan x is log of sec x. That is log of sec v. Integration of 1 upon x is log x. So log of v. Integration of 2 upon x, that is 2 of log x plus c. And everything सबके सबके यहाँ पर log है तो यहाँ पर भी आप log c ले लो. Right? Log sec v minus log v will be log of sec v upon v is equals to log of x square into c. Fine. Then you can cancel log and log on both sides. So sec v upon v is equals to x square c. Finally, what was the value of v? That is y by x. So sec of y by x upon y by x is equals to x square c. Fine. After this, sec of y by x is equals to y by x into x square c. This x and this will get cancelled. So what you get ultimately is sec of y by x is equals to yx into c. Fine. That's it. So finally you get the value of this. This is what your general differential equation. Required solution of the given differential equation. Yeah, is the required general differential is the required general solution. क्लियर है? ठीक है, ये सारे क्वेश्चन ऑलमोस्ट सिमिलर ही है. We'll try to solve this ninth problem again. Okay, now see over here the ninth problem कैसे solve करना है. ठीक है, पहले तो आपको ये चेक करना है कि whether the given differential equation is homogeneous or not. ठीक है, फर्स्ट यू हैव टू चेक दैट. नाउ पहले होमोजेनियस है या नहीं उसे चेक करने के लिए आप dy by dx के फॉर्मेट में पहले लेके आओ. सो व्हाट यू हैव y dx प्लस x log of y by x into dy minus 2x into dy is equals to 0. Fine. So y dx will be equal to, if I take everything on the right hand side, it will be 2x dy minus x log of y by x into dy. If I take dy is in common, so y dx will be equal to 2x minus x into log of y by x into dy. Fine. If I take x in common in this, it will be x into 2 minus log of y by x into dy. So what you get dy by dx as, if I take everything on the left hand side, so y upon x into 2 minus log of y by x will be equal to dy by dx. So what you get? Your dy by dx is equals to y upon x into 2 minus log of y by x. अब यहाँ पर आप बिना पुट करे भी आप देख सकते हो. अगर देखो यहाँ पर y के यहाँ पर लैम्डा y लिखा, x के यहाँ पर लैम्डा x लिखा और इसमें लैम्डा x लैम्डा y एंड लैम्डा x लिखा, तो इसमें लैम्डा लैम्डा ऑटोमेटिक कैंसिल हो जाएगा. इसका और इसका लैम्डा बाहर बाहर से कैंसिल हो जाएगा. therefore what we can say, the given differential equation is homogeneous. What we can say, that the given differential equation is homogeneous. What it is? It is homogeneous. Now, if it is homogeneous, then what we can say? We will try to put y is equals to vx. We'll put y equals vx. And if I differentiate, what I get? Dy by dx equals v plus x dv by dx. फाइन. तो आप पहले इसे लिखो. ये आपको गिवन था, राइट? dy by dx can be written as v plus x dv by dx is equals to y can be written as vx upon x into 2 minus log of vx upon x. Yeah. So what you get? This x gets cancelled. This x gets cancelled. What you get is v plus x dv by dx is equals to v upon 2 minus log v. Okay. If I take this v on that side, so x dv by dx is equals to v upon 2 minus log v minus v. Now if I do the cross multiplication, x dv by dx is equals to 2 minus log v, and this is v minus 2v minus 2 log x. Sorry, 2v minus v log v. Okay. So what you get? X dv by dx is equals to v minus 2v is minus v minus v log v upon 2 minus log v. Fine. 2v minus log v. Okay. Now, what I can do? I can take minus v as in common. So x dv by dx is equals to, if I take minus v as in common, it will be 1 plus log v upon 2 minus log v. Yeah. So if I take this dx on this side and this all terms on the left hand side, so dv into what you get? 2 minus log v upon minus v into 1 plus log v is equals to 1 upon x into dx. Is this clear? Yeah. अब यहाँ पर क्या करते हैं कि ऊपर 1 plus log v लेकर आता है, right? What we can do, if I multiply this minus in the numerator, what I get? Log v minus 2 upon v into 1 plus log v equals 1 upon x into dx. Fine. इसके बाद I need log v plus 1. So what I will do, I will add 1 and minus 1 over here. So 1 plus log v minus 2 minus 1 upon v into 1 plus log v equals 1 upon x into dx. Okay. So if I इन दोनों को अगर मैं डिवाइड करूँ तो what I get is 1 by v minus 3 upon v into 1 plus log v is equals to 1 upon x into dx. Yeah. यहाँ पर क्या हुआ है कि ये माइनस v है ना, so minus v into 2 is minus 2v. Minus into minus, this will be plus, and plus v log v. Okay. After this, what you have is x dv by dx is equals to v minus 2v is minus v. So what you get? V log v minus v upon 2 minus log v. Okay. Now you will take everything on the left hand side as the values which you have in terms of v. So what you have? 2 minus log v upon v log v minus v is equal, then dv is equals to 1 upon x into dx. Okay. If I take v in common in this, what you get? 2 minus log v upon v in common. So what you get? Log v minus 1 dv is equals to 1 upon x into dx. Fine. Now what you can do? We'll try to make log v minus 1 over here. Yeah. Now if I do plus 1 and minus 1, that is 2 minus log v plus 1 and minus 1. I will do minus 1 over here. The whole divided by v log v minus 1 dv equals 1 upon x into dx. Fine. Now minus 1 plus 2 will be 1 minus, if I take in bracket, it will be log v minus 1 upon v log v minus 1 dv is equals to 1 upon x into dx. Fine. If I divide this and this, what I get? 1 upon v into log v minus 1 minus this upon this, it will be 1 upon v into dv equals 1 upon x into dx. Fine. If I do the integration on both the sides, now it can be integrated. Okay. So it will be integration of 1 upon v log v minus 1 dv minus integration of 1 upon v into dv is equals to integration of 1 upon x into dx. ये तो आपका इंटीग्रेट हो जाएगा, ये भी इंटीग्रेट हो जाएगा. What about this? Yeah, डेरिवेटिव ऑफ log x is 1 upon x ना, तो ये 1 upon v अगर मैं ऊपर लिखे गया तो अपॉन log of log v minus 1. अब नीचे का डेरिवेटिव ऊपर है, तो what I can write is equals to integration of 1 upon x dx. So now what I can say, the derivative of this is there in the numerator, so I can say integration of this will be log of log v minus 1, integration of this will be log v is equals to integration of this will be log x and plus log c. Okay, so now this and this are in subtraction, so it will be log of log v minus 1 upon log v is equals to log of xc. This log and log can be cancelled. Now log v minus 1 upon log v, log v upon log v is 1 minus 1 upon log v is equals to xc. Yeah, so 1 plus, sorry, 1 minus xc, or you can say, yeah, 1 minus xc will be equal to 1 upon log v. Yeah, so this will be your general solution, and after that you have to also write what is a log v. 1 upon log v can be written as minus log v. This minus, if I multiply over here, it will be xc minus 1 will be equal to log v. And but what is v? What is v? That is y by x. So xc minus 1 is equals to log of y by x. And if this minus 1 comes on this side, so xc is equals to log of y by x plus 1. That's it. Yeah. So this is what your required general solution. Clear है everyone? Yeah. नाउ अभी आगे आगे की सम्स में देखो. नाउ यहाँ पर आपको दिया है फॉर ईच ऑफ द डिफरेंशियल इक्वेशन इन एक्सरसाइज लेवल टू 15 फाइंड द पर्टिकुलर सॉल्यूशन सेटिस्फाइंग द गिवन कंडीशन. पर्टिकुलर सॉल्यूशन में क्या होता है? पर्टिकुलर सॉल्यूशन में यही है कि आपको अगेन जनरल सॉल्यूशन फाइंड करना है, लेकिन आप जो सी लिखते हो वो सी का वैल्यू भी फाइंड करना है और फिर वो सी का वैल्यू पुट अप करके सॉल्व करना है. ठीक है. सो विच वन यू वांट मी टू सॉल्व? लेट्स सॉल्व दिस 14th क्वेश्चन. ओके, ये 14th वाला क्वेश्चन सॉल्व करते हैं. What you have, dy by dx minus y by x plus cos of y by x equals 0. ये आपको differential equation given है and you have to find the particular solution in this. So आपका dy by dx minus y by x plus cos of y by x is equals to 0. Now it can be seen easily that it's a homogeneous. ठीक है, अगर y को अगर मैंने लैम्डा y और x को मैंने लैम्डा x रखा, ये लैम्डा लैम्डा यहाँ पर कैंसिल, यहाँ पर भी लैम्डा लैम्डा कैंसिल हो जाएगा and it will be the same equation. That's why it's a homogeneous general solution, homogeneous differential equation. So what you can put now, put y is equals to vx, therefore dy by, लेकिन before yeah, so dy by dx will be equal to v plus x dv by dx. Okay, so what you can write over here, instead of dy by dx I can write it as v plus x dv by dx minus vx upon x plus cos vx upon x equals 0. X cancel, x cancel. So what you have, v plus x dv by dx minus v plus cos v इज इक्वल्स टू 0। तो यहाँ पर v और v भी कैंसिल हो जाए v और v भी कैंसिल हो जाएगा, राइट। सो व्हाट यू हैव, x dv by dx is equals to minus cos v, yeah. So this dx goes on that side, so dv upon 1 upon cos v is equals to minus 1 upon x into dx. So I can also write this as sec v dv is equals to minus 1 upon x into dx. Yes or no? There is a problem. यहाँ पर cosec था. This was cosec in this. So यहाँ पर end तक भी हर एक में cosec ही आएगा. Over here also it should be cosec. Over here also it should be cosec. And if it is cosec v, this will be sin v. Got it? This will be sin v dv minus 1 upon x dx. Now you can integrate easily, right? So what you can do, integration of sin v into dv equals minus integration of 1 upon x into dx. Now integration of sin is what? Minus cos. Minus cos v equals integration of 1 upon x is log x plus plus what? Plus log c. Now what you can do? ये आप सब जगह माइनस में मल्टीप्लाई करोगे तो what you get, cos v equals log x minus log c. But this minus log c can again be written as plus log c. So cos v is equals to log of x plus log c. Log c1 you can say. So cos v is equals to log of xc. But what was v? The value of v is y by x is equals to log of xc. Now let us find what is the value of c. We have given when x is 1, y equals 0. What they have given? When x equals 1, at that time the value of y is 0. Okay. So cos of y upon x, that is 0 upon 1, is equals to log of c. 0 upon 1 is 0 only, and cos 0 equals log c, and then cos 0 is 1 equals log c. So log c equals 1. Log of what is 1? We know that log of e is 1. Therefore c equals e. Got it? The constant is e. अब यहाँ पर आपके पास जो जनरल सोल्यूशन मिला था, राइट, इसके अंदर आप बिना c के लिखोगे, c का वैल्यू पुट अप करके लिखते हो, देन इट इज अ पर्टिकुलर सोल्यूशन, दैट्स इट। therefore यहाँ पर c के बदले क्या आ जाएगा, e is the required particular solution. Is that clear everyone? Okay, so by the time start solving this 15th question, I'll be back in a minute. ठीक है, चलो देखो यहाँ पर I will be solving the 15th question also. See over here how we can solve this. Now यहाँ पर आपको क्या given है, 2xy plus y square minus 2x square into dy by dx equals 0, right? Okay, no problem Muskan, I'll see to it how we can solve this. Okay, तो यहाँ पर पहले तो ये डिफरेंशियल इक्वेशन आपका होमोजीनियस है या नहीं वो आप चेक करोगे, राइट। सो पुट y इज इक्वल्स टू, अब पहले dy बाई डी एक्स इक्वल्स निकालो क्या आता है। तो व्हाट यू कैन राइट, अभी अगर आपने ये इस तरफ ले लिया तो व्हाट यू गेट 2xy प्लस वाई स्क्वायर इज इक्वल्स टू 2x स्क्वायर इंटू डी वाई बाई डी एक्स, एंड देन you can write your dy by dx is equals to 2xy plus y square upon 2x square. As you can see it's simply, आपको दिख ही रहा है यहाँ पर कि that the given differential equation is homogeneous, ठीक है। बिकॉज अगर x को मैंने अगर लैम्बडा x रखा और y को लैम्बडा y रखा तो लैम्बडा स्क्वायर हो जाएगा, यहाँ पर भी लैम्बडा स्क्वायर हो जाएगा, और यहाँ पर भी लैम्बडा x रखा तो लैम्बडा स्क्वायर हो जाएगा, लैम्बडा सब जगह पे कॉमन, और लैम्बडा लैम्बडा स्क्वायर कैंसिल, राइट। therefore what we can say, therefore the given differential equation is homogeneous. What it is? Homogeneous. Now if it is homogeneous, what we can do, I can put y is equals to vx, right. So your dy by dx will be equal to v plus x dv by dx, right? So यहाँ पर again let's take this equation from here. Yeah. तो यहाँ पर आप dy by dx के यहाँ पर क्या लिख सकते हो, v plus x dv by dx is equals to 2x vx plus vx the whole square upon 2x square. Fine. Now what you get? V plus x dv by dx is equals to 2vx square plus v square x square upon 2x square. I can take x square as in common in this. So v plus x dv by dx is equals to, I can take x square in common, so it will be 2v plus v square upon 2x square. So this x square will get cancelled. Finally, what you have is v plus x dv by dx is equals to 2v plus v square upon 2. Now if I take this v on this side, what you get? X dv by dx is equals to 2v plus v square upon 2 minus v. Yeah. So you have x dv by dx is equals to 2 in the LCM. It will be 2v plus v square minus 2v. Yeah. So your 2v gets cancelled. What you get ultimately is x dv by dx is equals to v square by 2. Yeah. After that, you can take dx on this side. So आपका आ जाएगा dx 1 upon v square equals dx and this will come in the denominator और ये आपका 1 upon 2 as it is. So what you have is v raised to minus 2 into dv is equals to 1 upon 2 into 1 upon x into dx. If I take integration on both the sides now, what you get? Integration of v raised to minus 2 will be v raised to minus 2 plus 1 upon minus 2 plus 1 is equals to 1 upon 2 log of x plus c. So what you get? V raised to minus 1 upon minus 1 equals 1 upon 2 log of x plus c. Finally, it will be minus 1 upon v equals 1 upon 2 into log x plus c. Fine. But what was v? That was y upon x. So minus x upon y will be equal to 1 upon 2 log of x plus c. तो ये आपका जनरल सोल्यूशन बन गया. But what we need the particular solution. So what we will need, अब यहाँ पर इन्होंने given है कि when x equals 1 at that time y equals 2. Fine. When x equals 1, when x equals 1 at that time the value of y equals 2. So let's put that value. So minus 1 upon 2 is equals to 1 upon 2 log of 1 plus c. Log 1 is, what is the value of log 1? Log 1 is always 0. So minus 1 upon 2 equals, ये तो पूरा 0 हो जाएगा, c. So the value of c is minus 1 upon 2. Just a moment. एक मिनट. ये 1 upon 2 into log x. हाँ. ये 1 upon 2 ये पूरे इसमें बाहर है ना. So this will be outside actually. Yeah. This will be outside. So if I put over here, this 1 by 2 will remain over here. This is minus 1 upon 2 equals c upon 2. Okay, this will be 0. So this 2 and 2 will get cancelled. The value of c is minus 1 ultimately. So now you can again write the same differential equation with the value of c so that that will be the required particular solution. So what you get? Minus x by y is equals to 1 by 2 log of x minus 1 is the required particular solution. Is that clear everyone over here? Clear है सबको how to solve, how to get the particular solution? If anyone has any doubt, you can ask your doubts please. If it is clear, please type clear in the chat box. Now I'll take the next question. The next is linear differential equation. ठीक है? What is linear differential equation? देखो आपका linear differential equation में आपका differential equation कुछ इस तरीके से होना चाहिए. dy बाई डी एक्स प्लस पी वाई इज इक्वल्स टू क्यू। अगर ऐसे फॉर्मेट में अगर आपका डिफरेंशियल इक्वेशन है तो आप डायरेक्टली इसका सोल्यूशन निकाल सकते हो। द सोल्यूशन ऑफ दिस डिफरेंशियल इक्वेशन विल बी दिस, वेट आई विल टेल यू। सी, अगर आपका डिफरेंशियल इक्वेशन अगर ऐसा है, दैट इज dy बाई डी एक्स प्लस पी वाई इज इक्वल्स टू क्यू, वेर पी एंड क्यू आर कांस्टेंट और फंक्शंस ऑफ x ओनली। यहाँ पर dy बाई डी एक्स है ना, सो ये p और q क्या होने चाहिए? इट शुड बी कांस्टेंट और फंक्शंस ऑफ x ओनली होंगे। तो व्हाट वी कैन डू, वी हैव टू फाइंड द इंटीग्रेटिंग फैक्टर। इंटीग्रेटिंग फैक्टर कैसे निकालोगे? e रेज टू इंटीग्रेशन ऑफ p dx। ये p का जो वैल्यू है, ये p आपको यहाँ पर पुटअप करना है और इंटीग्रेटिंग फैक्टर निकालना है, एंड देन द सोल्यूशन ऑफ द गिवन डिफरेंशियल इक्वेशन विल बी दिस। सिमिलरली अगर इक्वेशन आपका dx बाई dy, यहाँ पर dy बाई dx है और यहाँ पर dx बाई dy है, गॉट इट, एंड इट इज p1x इज इक्वल्स टू q1, यू कैन से px इक्वल्स q, तब आपका डिफरेंशियल, आपका जो सोल्यूशन ऑफ द डिफरेंशियल इक्वेशन ये होगा, दैट इज x इनटू इंटीग्रेटिंग फैक्टर इज इक्वल टू इंटीग्रेशन ऑफ q इनटू इंटीग्रेटिंग फैक्टर dy प्लस c, और यहाँ पर भी it will be integration over here and this will be there. Okay, so based on this only we'll be solving the further exercise. Now see to it, we'll solve the further exercise. I'll write this as linear differential equation. ये linear differential equation का यहाँ पर आपके key notes हैं, यहाँ पर we'll be using this in the solving part. Okay, now let's take some examples based on this. Okay, given find the general solution, और यहाँ पर एक मिनट, तो एज यू कैन सी द फर्स्ट क्वेश्चन, ओके, तो यहाँ पर आपका फर्स्ट क्वेश्चन क्या है, दैट इज dy बाई डी एक्स प्लस टू वाई इज इक्वल्स टू साइन एक्स, बराबर। हमारे पास लीनियर डिफरेंशियल इक्वेशन में देखो ये है dy बाई डी एक्स प्लस पी वाई इज इक्वल्स टू क्यू, वेर p एंड q कैन बी अ कांस्टेंट और अ फंक्शन ऑफ x ओनली। तो यस, इट इज अ फंक्शन ऑफ x ओनली, यहाँ पर ये 2 और ये साइन x। ओके, सो यहाँ पर व्हाट वी कैन से over here, comparing with dy by dx plus py is equals to q, so what you get, therefore p equals 2 and the value of q equals sin x। तो इसमें पहले तो आपको इंटीग्रेटिंग फैक्टर निकालना होगा। योर इंटीग्रेटिंग फैक्टर इज e रेज टू इंटीग्रेशन ऑफ p dx, that is e raised to integration of p, the value of p is 2 and the dx, integration of 2 will be 2x, so it is e raised to 2x। ये आपका इंटीग्रेटिंग फैक्टर आ गया, या, एंड नाउ व्हाट यू नीड, आपका जो इसका जो सोल्यूशन होगा वो ये होगा, एज आई हैव एक्सप्लेन टोल्ड यू ऑलरेडी, दैट इज इसका जो आपका सोल्यूशन होगा वो इस तरीके से होगा, ये वाला होगा, दैट इज व्हाट, y into integrating factor, what it will be, y into integrating factor will be equal to q into integrating factor, okay, or integration of dx plus c, fine। So y into integrating factor आपका क्या है, e raised to 2x, that is into e raised to 2x is equals to integration of, what is the value of q, the value of q is sin x into integrating factor, that is e raised to 2x and then dx plus c। आप लोगों ने इंटीग्रेशन भी किया है, राइट, पार्शियल इंटीग्रेशन भी किया है, u इंटू वी इंटीग्रेशन किया है, यहाँ पर लिएट यूज करते हैं, राइट, एक्सपोनेंशियल सबसे लास्ट आता है तो एक्सपोनेंशियल आपका आगे ही होगा, राइट। तो आपका साइन एक्स इंटू ई रेज टू टू एक्स डी एक्स में प्लस सी, दिस विल बी योर u एंड दिस विल बी योर v, ओके। तो y इंटू ई रेज टू टू एक्स इज इक्वल्स टू u इंटीग्रेशन v, that is sin x into integration of e raised to 2x minus integration of integration e raised to 2x, then derivative of sin x and then plus c, right? So what you get, y e raised to 2x is equals to sin x, now integration of e raised to x is e raised to x only, so e raised to 2x, then further derivative of this 2x will be divided, okay, so that will be divided by 2 minus integration of again e raised to 2x is e raised to 2x by 2, and then derivative of sin x is cos x plus c. So what you get? Y into e raised to x 2x is equals to e raised to 2x into sin x upon 2 minus 1 upon 2 integration of this e raised to 2x into cos x. Now what you will get? Now यहाँ पर again you have to do u into v. Again the cos x will come later on. पहले आपका cos x आएगा और बाद में आपका e raised to 2x and then dx and then plus c. Fine. So y e raised to 2x is equals to e raised to 2x into sin x upon 2 minus 1 upon 2 integration of this, that is cos x, integration of cos e raised to 2x is how much? E raised to 2x upon 2 integration of this minus integration of e raised to 2x upon 2 derivative of cos x is minus sin x dx. Fine. What you get ultimately? Y e raised to 2x equals e raised to 2x into sin x by 2 minus 1 upon 2 into this minus 1 upon 4 cos x into e raised to 2x minus into minus, this minus into minus it will be plus, and then minus into plus will be minus e raised to 2x into sin x upon 4. Yeah, so this and this will get cancelled. No, it will not get cancelled because यहाँ पर 1 by 2 है और यहाँ पर 1 by 4 है, right? So what we can do, e raised to 2x sin x upon 2, तो ये half minus 1/4 will be 1/4. So y e raised to 2x will be equal to 1 by 4 e raised to 2x into sin x minus 1 by 4 e raised to 2x into cos x. Yeah, I can write this. Now 1 by 4 or e raised to 2x सब कुछ I can take it as common. Yeah. So what I can do, if I take e raised to 2x as common in all of them, what I get 1 upon 4 sin x minus cos x plus c. So is the required general solution, and if you put the value of x into this, you will get the particular solution. नहीं, इन्होंने यहाँ पर सिर्फ जनरल सोल्यूशन फाइंड करने वाला है. That's it. हो गया आपका यहाँ पर जनरल सोल्यूशन फाइंड. Is that clear? Now the next time I'll give you to solve. Try solving this fifth question. I'll be back in a minute. देखो यहाँ पर if I want to solve this fifth question, what you have this as the differential equation, right? So what you have, cos square x dy by dx plus y equals tan x. If I divide with cos square x throughout the equation, what I get? Dy by dx plus y upon cos square x equals tan x upon cos square x. बराबर? So dy by dx प्लस पी वाई, जैसे पी वाई की यहाँ पर 1/cos² x इंटू वाई, मतलब इस वैल्यू को मैं p कंसिडर कर सकता हूँ, इज इक्वल्स टू दिस tan x कैन बी रिटन एज sin x by cos x एंड दिस इज 1/cos²x. तो क्या हो जाएगा, cos एंड दिस स्क्वायर विल गेट कैंसल्ड. व्हाट यू गेट, dy by dx प्लस 1/cos² x इंटू वाई इज इक्वल्स टू व्हाट, ये 1/cos x ऊपर जाएगा तो sin x इंटू cos x हो जाएगा. Now we can do what, comparing with what, dy by dx plus py is equals to q. So what do we get, the value of p is 1/cos²x and the value of q is sin x into cos x. बराबर. I can also say that the value of p is sec²x and the value of q is sin x into cos x है ना. या यहाँ पर भी मैं इसे ऐसे करता हूँ. This tan x can be written as, this can be written as sec² x into tan x. Yeah. Similarly, I'll write over here also. can be written as sec square x into tan x. Similarly, over here, the value of q will be sec square x into tan x. बराबर, this is also sec square x into tan x. p और q का value मिल गया, right? Now we need integrating factor. Integrating factor will be e raised to integration of p dx. p का value sec square x इसलिए रखा because integration of sec square x is possible. Integration of sec square x dx. What is the integration of sec square x? Derivative of tan x is sec square x, so integration of sec square x is tan x. So it is e raised to tan x, right? तो आपको integrating factor मिल गया, that is e raised to tan x. Now the general solution हमने जो formula से पढ़ा था, that is y into integrating factor equals q into integration of what you have, y into integrating factor equals integration of q into integrating factor and then dx plus c. Got it? तो यहाँ पर y into integrating factor क्या है आपका, e raised to tan x equals integration of q का वैल्यू कितना है, sec square x tan x, and the integrating factor, that is e raised to tan x dx plus c. फाइन. नाउ आपका ये हो जाएगा y into e raised to tan x is equals to integration of sec square x into tan x into e raised to tan x dx. Okay, if I put tan x equals t, then your sec square x dx will be equal to dt. तो यहाँ पर ये as it is लिखेंगे, y into e raised to tan x is equals to integration of sec square x can be written as sec square x dx can be written as dt. Now tan x is t and this is e raised to t and this is dt. Fine. So integration of t into e raised to t, y into e raised to tan x equals integration of t into e raised to t. अब अगर आप लिएट में जाओगे तो एक्सपोनेंशियल सबसे लास्ट, तो बराबर है, एक्सपोनेंशियल आगे होगा, अलजेब्रिक पहले होगा. So this will be t into integration of e raised to t minus integration of integration e raised to t, derivative of d by dt of t and then dt. Fine. So this will be y into e raised to tan x equals t into integration of e raised to t is e raised to t minus integration of this is also e raised to t and derivative of t is 1. Okay, again integration of e raised to t will be the same thing, e raised to tan x equals t into e raised to t minus integration of e raised to t is again e raised to t. Fine. You can take e raised to t as in common. y, wait, y into है ना यहाँ पर, y into e raised to tan x is equals to, if I take e raised to t as in common, it will be t minus 1. And now what is the value of t? T is tan x. So y into e raised to tan x equals e raised to tan x into tan x minus 1. यहाँ पर दोनों जगह e raised to tan x कैंसिल हो जाएगा. बचेगा क्या आपका, y is equals to tan x minus 1. एक मिनट, यहाँ पर c भी है ना, या प्लस c. That's it. This is what your required differential equation of the is the required general solution. Is the required general solution. Is this clear, everyone? Let's do this seventh. Now what you have? X log x into dy by dx plus y equals 2 by x into log x. Fine. This is what you have. अब क्या करना है, पहले dy by dx के फॉर्मेट में लेके आना है, right? तो what we can do in this, so x log x into dy by dx will be equal to 2 upon x into log x minus y. Okay, and this x log x can be taken in the denominator. After that, dy by dx will be equal to 2 by x into log x minus y upon x log x. Fine. Now if I solve this, dy by dx is equals to 2 by x log x upon x log x will be 2 by x log x into x log x, मतलब ये square log x minus y upon x log x. क्या हो जाएगा, ये log x cancel. So what you get, dy by dx प्लस अगर ये इस तरफ आ गया तो 1 upon x log x into y is equals to 2 upon x square. So यहाँ पर comparing with what, comparing with what, that is dy by dx plus py is equals to q. Okay, so the value of p will be 1 upon x log x and the value of q will be 2 upon x square. Okay, so आपको p और q दोनों का वैल्यू मिल गया, right? Now what you can do, let's find the integrating factor. Your integrating factor will be e raised to integration of p dx. So it will be e raised to integration of 1 upon x log x dx. अब यहाँ पर अगर आपने log x को t put up किया तो 1 upon x dx will be dt. So it will be e raised to integration of 1 upon t into dt. That is e raised to integration of this will be log of t. यहाँ पर base e ही है, so answer will be t only. Okay, तो आपको integrating factor क्या मिला, t. But what was t? T was log x. Fine, your integrating factor आपको मिल गया log x. अब इसका solution अगर आपको लिखना है, the general solution will be, the general solution is what, y into integrating factor equals integration of q into integrating factor and then plus c. Okay, so y into integrating factor is log x equals integration of q. What is q? 2 upon x square into log x plus c और यहाँ पर dx. Okay, so y log x equals integration of, now log x upon x square, you have to integrate this. So again लिएट अगर आप करोगे तो लॉगरिथमिक सबसे पहले आता है, तो 2 आप बाहर ले लो, log x you can take it over here and this is 1 upon x square and this is dx plus. Fine, so y log x is equals to 2. Now अगर आप u into v करोगे तो u is log x, that is log x into integration of 1 upon x square dx minus integration 1 upon x square dx. Now derivative of log x is 1 upon x and then dx. Integration of 1 upon x square, integration 1 upon x square dx, then derivative of log x is 1 upon x and then dx. Okay, everything is fine. Okay, now y log x is equals to 2 into log x. Now integration of 1 upon x square will be x raised to minus 2, x raised to minus 2 का आ जाएगा x raised to minus 1, x raised to minus 1 upon minus 1 minus integration of this will be x raised to minus 1, that is minus 1 upon x square, sorry minus 1 upon x, minus 1 upon minus 1, yeah, minus 1 upon x dx minus 1 upon x into 1 upon x into dx. Fine, so what you have, y log x is equals to 2 into log x by minus x minus integration of 1 upon x square minus यहाँ पर आ गया तो plus dx. Now integration of this is again minus 1 upon x. So y log x equals 2 into log x upon minus x minus 1 upon x and then plus c. दोनों में अगर x अगर मैंने कॉमन ले लिया तो आपका x यहाँ पर आ जाएगा. तो एक्स वाई इंटू लॉग एक्स इज इक्वल्स टू minus 2 log x minus 1. So this will be minus 1 plus c. This will be your required general equation. Got it, everyone?
Yes, sir.
Yeah, fine then. So over here we are done for today. We'll continue this differential equation in the next class. Okay? Chalo then. Bye bye everyone. Have a good day.